Hello everyone. Now we are live. We'll be solving few DSA questions today. We'll be streaming for 10 hours continuous and we'll be solving a lots of DSA questions today. I'm very much excited for this and I was waiting for the weekends to come from all day. So it's time and now we can start our coding. So today I'm thinking of solving some Google related problems which are mostly the higher frequency ones. So there are lots of questions which are higher frequency. So I'm thinking of solving some problems which are green in color mostly for 6 months, and then we'll switch for 1 year and solve all the green, and then we'll switch for 2 years and then we'll solve all the green. So I'm trying to solve these questions right now. So let's see how much I can solve. But I've already solved many of them, but I'll go through each and every question again and again so that it gets into my mind, uh, the concept also, the logic also, and how to implement those concepts and logic differently, something like that. So we can do something like that. So let's start with some questions, and m- maybe I'll start with some hard questions because this is morning and in the morning our brains are mostly active, so I'm thinking of solving some hard level problems and then 2 3 hard level, and then we can go to medium level and easy level questions if there is any. Okay, so let me start my timer. Where is my Pomodoro? So what we'll be doing, we'll be generally taking a 50 minutes of coding challenge, and then will be taking a 10 minutes of short break. This will be continuous, and I think I'll take a 40 minutes or 50 minutes of a long break for my lunch, and we can come back again and we can start coding again. So this is my plan. So let's just start with the first Pomodoro. Let's go. So this is my first question. Let's pick a question which is named as range module, and then we can go for meeting rooms 3, maybe finding MK average also, and odd even jump. So first let's solve all the questions that I have already solved in the last 6 months. Finding MK average, I'll try to solve it because I had tried it but I was not able to successfully complete it. So I think I need to see the solution for this, and then we'll together understand the solution and then we can do it. Okay, let me remove. Okay, so basically what we have in this is we are given a range module. Okay, mm, just a second. Okay, yeah. So what we'll be doing is we will finding the range module question. In this, the question says will be given a range, will be we have to create some kind of data structure which will be handling these three operations. The operations is add range, query range, and remove range. These are the three operations that we need to handle um, in some way by creating a data structure. Okay, okay. So what the first function, which is add range? this will do, this will do nothing. This will add a range into my data structure. So the data structure is 10 to 20 in the first query. As you see in our example, this is my range module method. This constructor will be called. If we want to initialize something, we can do inside this constructor, else it will be empty if we want. Now the second thing which comes is add range. This add range will add a range that is 10 to 20 in our data structure. So this is just a range from 10 to 20. This we need to do in our data structure. Now we need to remove range. The second is remove range. So we know that we added a range from 10 to 20. If we can just manually type it, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 2020 is not included because it's an open interval. As you can see here, it's showing left is the closed interval, but right is not closed, it's open interval. So what we'll be doing on the right, we will not be including 20. Though even though we are writing this 20, but we will not be including this 20 in our solution for now. In this range 20 is not included. From 10 to 19 it's included. Okay. Now we need to remove range. Remove range from 10 to 14. So whatever is coming between 10 to 14, obviously 10 is included, but 14 is not included. 14 is an open interval, 10 is an closed interval. Okay, everywhere this is the same thing. 10 is the left part is the closed interval and the right part is the open interval. That's how we are trying to uh, incorporate this question. So we know that we need to remove a range from 10 to 15. So in within 10 to 15, what are the values that are coming? So we can see 10, 11, 12, 13. 14 is not included, so we'll not be including 14. So these four values are included, so we'll remove all this range. Now my range which is left is from 14 to 19. Obviously 20 is not included. Okay. Now the third query comes. Third query says query range. Now this is a query range. We already saw add range, which will add. Remove range, which will remove the range. If it is available, then it will remove. If it is not available, then will not remove. Now the third is query range. Now query range will do what? It will check in my data structure whether this range is present or not. All the values within this range, if it is present, then it will return true. If it is not present, then it will return false. Let's look at with an example. We have 13 and 15. From 13 to 15, see 13 is included but 15 is not included, so we need to query this range. So we can see 13 is already removed. We removed it in the previous query, correct? Remove range. So 13 is already removed, but we can see 14 and 15, but 15 is not included. 14 is there but 13 is not there. So in this case we will return false, because this query range says all the values within the query should be available inside our range. If it is not available, then uh, will return false directly. If it is available, if it would have been 14 to 16, something like that, so I'll be returning true because they are present in our range. But if it is but here it is 13 to 15, so we cannot include it in our solution. Okay, now another query range is, for this it will be false, correct, because 13 is not there. For the next query range, it's 16 to 17. As we can see, 16 to 17 is there. 17 will not include. We only need to watch 16. Okay, 16 is there, correct. Then we will add it in our answer solution and will return true in this case. In this query range, will return true. Okay. Okay, I think what we did, there were three query range and remove range was 14 to 16. Okay. No problem. I actually skipped the example, but you got the intuition what we need to do. At least we got the intuition that what we need to do and what is happening in the question. Correct? If you are watching and if you don't understand, then please let me know. I'll explain it again because this is very, very, very nice question and the logic behind solving this question is really amazing. So we have to keep um, understanding it as we go because if we anywhere we our flow stops, then we won't be able to understand the further part also. So we need to understand this very crystal clearly. Okay, fine. So if you don't understand, please let me know. I'll continue with the approach how we'll be solving this. If you want to try, you can pause it and then you can try it on your own. If else, we can try to solve it together. Let's solve it. We have add range method. Now, what we need to do, we need to add some range. So we need to create some kind of data structure. Now, I'll take an example. Suppose we added few range in our data structure. I'm not right now concerned about the data structure. I'm concerned about more of the logic, how our logic will be implemented, or what are the things that we need to handle before we go for deciding any data structure. So what we'll do is we have 10 to 20 in our range. Suppose this is a range that we added using add range. This is an add range. Okay. Now we have another range. Suppose 25 to 30, something like this. So we have a add range again. So these two are nowhere overlapping with each other. These two are separate intervals. So we have to handle these separately. Now we have query add range again. Now suppose there is an add range again and which says from 18 to 27. This is the add range again. Now if we can see over here, if you all can see, if this 18 is lying between this 10 to 20 and this 27 is also lying between this 25 to 30, that means what? From I can directly write that from 10 to 30 all the values are present within us with us. So instead of writing three separate intervals, we can write directly one interval that is 10 to 30. Think over it, think over it. Can we? Correct, no? If we can do this, we'll be 100% sure that okay, we can write it. So instead of handling these three queries differently, we can just merge those intervals and we can directly write 10 to 30 instead of that. That is one of the thing that we can do. Correct. Now, the next thing, uh, this is done. Now, if any query that is 35 to 40 comes or 42 comes, we won't be handling this inside this because they are not overlapping. But if there is a query that comes 30 to 36, something like this, so we know that, or even 35, even 35 also comes, 30 to 35 also comes. We know that there are intervals. So if you can see from 30, 30 is not included, but in this case left part is included. This is closed interval and this is open interval. So this 30 will be included. Okay. Now this 35 is included, but this 35 is not included. But still, there is one value which is handling this 35 and this 30. Correct. So we can see that from 10 to 42, we have all the values present over here. Okay, so we can we can directly say from 10 to 42 there are values present over there. So this is what add range will do. Add range will add all the ranges, uh, add it in our data structure. So now we need to handle this with some data structure. Okay, before handling this, let's see the remove range also. We can see the query range. Query range is not very much difficult, but let's see the remove range. What we now we have this interval. Now suppose these were the three add ranges that we had, and we merged those intervals into a 10 to 30 interval. Now we have another range, that is remove range. So remove range is nothing but 10 to 30. We from 10 to 30 we need to remove. So suppose we need to remove this range only, 14 to 16. So this range needs to be removed from here, correct? So what we will do in this case, we will handle this also separately. We know that 10 to 14, 14 is included, correct? My left is a closed boundary and right is open boundary. Now 10, 11, 12, 13, these all values will be there, but 14, 15 will not be there. 16 is open interval, so will not include that, but 16 is there inside this 10 to 30 interval. So from 16 to 30 there will be an interval. So we can see we now have two interval. 10 to 13 interval is a separate interval. There will be a gap of 2 between them, and then 16 to 30 interval. So you can see we created two intervals. So remove range will do what? Remove range, if there is a range between these intervals, then we'll remove those range and we'll separate the two intervals into two half. We need to do that. But if we don't have that, we can uh, if we don't see any range that needs to be removed, then we can directly we will do nothing. Like if we had 1030 and it says remove range 35 to 40, we'll do what? There is nothing, no interval present here between 10 to 30, which is 35 to 40. So we'll do nothing. We'll only do when the range is present. So this is my remove range. Now the third thing is query range. Now we need to see whether that query is whether all the values are present or not. So suppose the query comes like 12 to 18. This is my query range. Let me change the color. Maybe I'll get confused. This is my query range. If my query range is from 12 to 18, we can see 12 is present over there because 10 to 13 contains 12. 13 is also no, 13 is not there. So we can see 14 is not there, 15 is not there, 16 is there, 17 is there, 18 is there. But there are lots of values 13, 14, 15 which are not present over here. So that means what? In this case, these values are not present, so will return false. Will only return true if all the values are present. Now if another query comes which says from 16 to 18, suppose, so we can see 16 to 18 is present over here. All the values are present inside this, so will return true. In this case, will not return false because all the values are present in my interval. So return true, or if it is not present, will return false. So this is the simple way to solve this question. Hmm, simple logic to solve this question. Now we need to figure it out how we need to handle these merge intervals part, this separate interval part, and this query range part. So for this, what we'll do, we'll handle this with using a map. What we'll do, what this map will do. Let me show. Just a second. Okay, no problem. I think I am not able to do it on the on my this screen. Maybe I'll do this way only. Now, what we need to handle it with map. In C++, what map does is map contains two value, key and value. This is my key and this is my value. Now this key will contain a value key. This key will be sorted in ascending order from smaller to bigger. It will be sorted from in ascending order. This is the way map is handled in C++. We can also do with some unordered map, but unordered map will not help in this case. We need to handle it with directly with map only. So using map, we can handle this. So suppose there comes three queries, that is 10 to 20, and then add query again 25 to 30. We are only handling the add query part for now. And the third interval comes as suppose 20 to 25. Okay, these are the three intervals that is handled. Now we see 10 to 20 is present. Okay, 10 to 20 is present, so we can see in our map there is nothing present like 10 to 20, so we'll directly add this 10 to 20 in our map. Now the next query is 25 to 30, so we'll directly add this 25 to 30 because it is not clashing or overlapping with another uh, value or another interval, so we'll directly add 25 to 30. Now we see that 20 to 25 comes. So 20 to 25 clashes with this interval and this interval too. So we'll do what? We'll find a uh, upper bound. We have this 20 to 25. This is my left part and this is my right half. So what we'll do, we'll find a value upper bound for this left value. So we can see if we find an upper bound for this value, it is 25. Now we need to check whether this right value is beyond or even equals to this 25. We can see this right value is within this 25. That means what is coinciding or overlapping with 25. That means this interval will be merged with this interval that we encountered now. So these two intervals will be merged. How we know that? Because this right is equals to this left, IT ka left. Even this is, if this would have been a greater value like 26, so we know that 26 lies somewhere here. 26 will lie beyond this. So that means this interval and this interval will merge at any cost. So if it is not there, if the value is 24, then we can say that these two values will not merge with together. But if it is not, then if it is somewhere value which is 25, we can say that this will merge. Correct. So this way we are handling. So we know that this will merge. So what we'll do, will update my right with 30 because this will extend up to 30, and we'll remove this interval because we don't want this interval. This interval has already been included in the 20 to 30. So we'll remove this. Now we came to the end of the map because there is no interval below this, but we still have a interval which is just above this map. So we'll check a value interval which is just above and compare its second value with the left value, whether they are coinciding or not. So you can see they are coinciding with each other. Even this value uh, If this value would have been something lesser than 20, 19 or 18, so you can see this 19 or 18 will lie here, 19 will lie here, or 20 will lie here. So they all will also merge. So if they merge, what we'll do, we'll update our left with 10, and we'll also remove this interval. Now we'll add directly a single interval, that is 10 to 30. So this 10 to 30 will be added in this interval. So this is how we are handling the add range part, because we need to merge all the intervals, and then at the last we'll be uh, inserting that interval, that range, which is independent of any other interval, which is not dependent on any other, which is not overlapping with another interval. So this is how we are handling the add range part. Correct? Okay. If you'll have any doubt, you can ask me in the chat. We can discuss it even more if you want. So right now, what we have 10 to 30 as in our interval. Now suppose we have one more interval, that is 35 to 42. This is add range. Now we are coming to this remove range part. So we'll add, let me add two intervals, so that we can understand it more precise way. Two interval, that is suppose 10 to 30 and 35 to 42. Now we need to know, we need to check. Now comes the remove interval, remove range. Inside this remove range, we have left value. Suppose we need to remove from 28 to 40. These are the values that we need to remove. So now what we'll do, we can see if we remove this interval, you say 10 to 30, this 28 is lying within this. So the interval that will be left is 10 to 28. This interval, because 28 is not included, obviously. So 10 to 28 will be a interval, and from 35 to 42 will be shortened to 40 to 42. Right, correct. 40 to 42. This will be my new interval, which will be inside our map. Now how we are handling this? That is the main question. So let's just handle this part and see how we can handle it. Now we have 28 to 40. Now what we'll do the same query. We'll see left, we'll find upper bound for this. So this upper bound for 28 will go to 35. We went to 35 and we saw the same value, the right value. If my right value is beyond this interval, so we'll have a cut variable, cut end, maybe cut end or cut anything. I'll explain you why we are having a variable cut end, which will be initialized as with -1 at initially, or we can even initialize it with 0. There's not an issue. Now what we see is 35 is greater than 42. Now for 40 lies beyond this 35. That means this interval will be shortened. I don't know whether this interval will completely be vanished, or do we need to shorten this interval. Right now we don't know, but we know that we will short this interval. That's for 100% sure. This is what we know, that, but we don't know whether we need to shorten this interval or completely remove this interval. This is a doubtful part. For now, doesn't matter. What we'll do is we'll update my cut end with the maximum of whatever cut end has currently, and the value at the right, and the value at the second half. So we'll update our cut end with 42, and what we'll do, we'll remove this interval. Now there is no interval beyond this. So what we'll do, we'll do nothing. We'll even come now. We'll compare it with the previous element too, because we left a, a interval which is just previous. It might be possible that this interval contains a value which is greater. So in this case, which also needs to be shortened. So 10 to 30 needs to be shortened again. So we can see this left. Now this has a left part. This left is lesser than this 30. That means this left is also overlapping with this 30, this 10 to 30 range. Correct? So what we will do, we will uh, will update this 30 with 28. Okay, and we also removed this interval. Now what will happen? Now we need to see my cut end is 42 and my right is 40. There is a interval which was left. As we can see earlier, what was the interval that was left? 10 to 28 and from 40 to 42. This was the interval that was left after removing from 28 to 40. So we can see my cut end is at 42, my right is at 40. So what we did is we know that this interval has not been removed. So we'll add this 40 to 42 again inside our interval. Correct? If you'll have any doubt, you can ask. But I think this will be very much clearer if you will try on your own once and watch this video again. If you don't understand, try with 2-3 examples on your own and you will get it very much clearly that how we are approaching this question. Now we have a query range. Now query range will there will be nothing to do in our query range. Suppose the query comes from 14 to 27. Now this is my query range. We'll check the upper bound, same upper bound for this 14. For 14 it will come 40. Now we'll go one step backward and then we'll check whether this 14 to 27 lie this in this range or not. If it lies in this range, that means we'll return true. If it does not, then we'll return false. Simple. Query range is nothing. Query range is also very simple. You can try it by using 2-3 examples. So if you'll have any doubt, let me know. I'll explain it again. But for now, let's just code for our add range and for our remove range. Now, first, what we'll do is we'll create a map of int comma int. Let's just name it range. This will be a better way. Uh, okay, here comes left and right. We need to add this in our range. Now we'll do what? We'll find the upper bound of this left. Now while upper bound is not equals to m dot n, while it is not, sorry, range dot n and and the right value is if greater than or equals to it ka first. If this is the case, that means this is an overlapping case. So what we will do, we'll update our right with maximum of right or it ka second. We'll increase our it and what we'll do, will range dot erase previous of IT. So we'll remove this range. So as we see, what will this will do, this will check whether this is overlapping or not. If we can see over here, we we had we had three add ranges, that was 10 to 20, 25 to 30, and the another range is 18 to 27. Now we checked these two will be in our map because they are not overlapping intervals, so these will be separately kept in our map. Now 18 to 27, what will we check this up? We find upper bound for this. What we did over here, we found an upper bound for left. This is my left, and this is my right. We found upper bound for this left. We got 25. We'll get 25. Correct. Now, if my map didn't go out of bound, that means there is a value, there is an interval which is more than left present over here. So we'll do what, we'll check if my right is beyond this first. That means my 27 will lie somewhere here because 25 is smaller than 27. That means this interval 18 to 27 is overlapping with this 25 to 30 interval. So if it is correct, then we'll do what? We'll update my right with the maximum of right, whatever right has, or the value that is in present in our map, that is IT second. So we'll update it with 30. Now we'll increase our iterator. Now we need to remove this interval. So for removing this interval, we in C++ we increase the iterator and then erase the previous value, previous interval. So this pre will go previously and it will remove that interval. So range.erase will do that part. So this will make sure that our values will be present. Now there is one more interval that we left. So there is an interval that is 10 to 20. This 18 is we are also we can also see that this 18 is also overlapping with this 10 to 20 interval. So we need to handle this part also. So now we know. Now my iterator will either go to a value which is which is not overlapping, or it will go to a to end of our map. So we'll check if my IT is not equals to range dot begin. If it is not equals to the beginning of the range, what we'll do, we will check the same thing. We'll check whether my left is lesser than or equals to my IT previous of IT uh, previous of IT ka second. If this is the case, that means this is an overlapping with the previous interval. That means we need to remove that also. So instead of removing that, what we will do is we will add our right on its rate. So IT second will be equals to my right. I'll directly. If this is not the case, if it is not overlapping, so we'll simply add in our range left is equals to right. So this will handle all the interval part that we discussed in before. Now we have remove range. Now in this remove range, we need to handle the remove part. So we'll do the same thing. We'll do IT of range dot upper bound of left. We'll find the upper bound of left. We'll keep a variable cut end with -1. Now the same logic will be applied if IT is not equals to range dot end and mm, 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 mm. And in my right is greater than or even equals to my IT ka first, then this is an overlapping case, then we need to shorten this. So my cut end will be updated with maximum of cut end or IT of second. Now this is my cut end. Now what we will do, after this cut end, we updated this cut end. Mm, Now we need to remove this interval. So we'll increase the iterator and range dot erase previous of IT. Correct. So this will be removed. Now there is an interval that we left. So if IT is not equals to range dot begin and end IT second of IT, uh, second of IT. So my left, if my left is also overlapping, that means if my left is greater than or even equals to IT ka second. No, sorry. My left is lesser than or equals to IT ka second. That means this is an overlapping case. So if my left is lesser than equals to IT ka second, then just a second. Oh, then what do we need to do? Uh, 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 hmm. Then we will update my IT ka second will be updated with left, because that is the part we need to cut. So from there it will be this and correct. This is the only thing that we need to do. Now this is now if my cut end is greater than or even equals to my right, I'll insert in my range right corresponding cut end. Now these two are my add range and my remove range. Now I need to handle the query range. Now for query range also we'll do auto IT is equals to range dot upper bound of left, upper bound of left. Now we need to check if IT is equals to range dot begin. So we'll directly return false, else will return previous of IT previous of IT. Okay, second we need to handle is lesser than sorry, is should be greater than or even equals to my right? So I think this will do my part. Maybe I'll just try and run this and see if we are facing any issue. Bool, where is Bool? At line number 32. If IT is not equals to begin. Okay, uh, 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 we are getting true for this query range. That means there is something that we are missing. Uh, previous of IT का second is should be greater than uh, should be only greater than, right? And this will be equals to. So we went to previous, we saw its second. It should be greater than or equals to R, right? Are we missing anything? Uh, are we missing anything? Upper bound of left. If it is not equals to range dot end and right is greater than or even equals to it का first, that means this interval needs to be updated. So cut end will be updated with cut end or it का second it plus plus range dot erase previous of it. Now if it is not equals to range dot begin, if it is not at the begin and oh okay, we need to make it previous. Then previous of it of second. So here also it will be previous. Okay, if it is not equals to and my left is lesser than or equals to previous of it का second, so then previous of it of second will be updated with directly will be updated with my right. Else will add a range of left to right. Remove range. If my right is greater than or even equals to it of first, that means this is the case. Cut end will be maximum of it second. It plus plus range dot erase previous of it. correct. If it is not equals to range dot begin and my left is lesser than or even equals to my previous of it equals second, then previous of it equals second will be I need to cut that half, so it will be updated with my left. If cut end is still greater than or equals to right. Oh, okay, I need to update here my cut and will be equals to maximum of cut and or okay. Now I think it's working. Let's submit it and see if we are facing any issue. Yeah, we are. We'll do it instead of doing every time previous. We'll do it directly. If left is lesser than equal to previous. Are we missing something if right is greater than equals to IT first? IT second. IT second is equals to left. Cut and is greater than equals to right. Range of right with updated with cut end. Even what is the thing that I am missing? I'll compare it. I don't think that I'm doing anything wrong. Mm, okay, okay. There's one thing I forgot to handle. Uh, Nothing else. The only thing that I forgot is while updating this right, I need to keep maximum of IT second and right. whosoever will be maximum will be updated over there. Oh, correct. Now this time it's updated. So the time complexity for this question will go to n log n. Maybe let's see with analyze complexity. It's O of log n. So we are doing is we are adding the range. If it will go to n log n times for now, but for querying and everything it will go to log n only. So this is the way how we solve this range module question. Okay, perfect. So then after this question we'll approach with meeting room and then odd even jump. These two questions are also very good questions. So let's take a break for 10 minutes and then we can start. Okay, so we are back. Let's solve another question, which is meeting rooms 3. So, so, so we'll be solving another question, which is meeting room 3. So in this question, what we need to do is we are given an integer n, and there are total of n rooms starting from 0 to n minus 1. Now we are also given some start interval and some end intervals. So we have a meeting room, multiple meeting rooms. Suppose there are n meeting rooms, n is equals to 3. So we have 3 meeting rooms, and there are multiple meeting that needs to be done inside in this meeting room. So if we can see, meetings start I and end I, and this also is same thing. Start interval will be a closed interval, and an interval will be an open interval. So all the values from start I are unique, and start I are unique values. Now what we need to do, we need to allocate all the meetings. So this is the meeting array, and we need to add all these meetings in our meeting room. This 0 to 10 will be added over here. If we started with indexing, so this 0 to 10 will be added in this interval, in this meeting room. This 1 to 5 will be added in this meeting room. This 2 to 7 will then need to wait until and unless a meeting room becomes empty, because there is no meeting room further left. So there is a meeting room that will be empty at time 5, which is the minimum time, so which is allocated to meeting room 1. So then, so 2 to 7 will wait till 5. So now we know the interval is 7 to 2. Now 7 minus 2 will be 5. So this meeting will go till 5, maybe hours, if we suppose, or minutes, anything we can take unit. So this will go for 5 hours. Now the one meeting room that was empty at 5 is meeting room 1. So the another meeting room, instead of starting from 2, it will start from 5, and it will go till 5 hours, that is 5 to 10. Now the next meeting room that comes is 3 to 4, but there is no meeting that is empty yet, so it will wait till 10, because this is the minimum time now where the meeting will be empty. So 10 at 10 both meeting rooms will be empty, so we need to allocate it with to the minimum meeting room. So the minimum, for minimum, we will allocate it here. So from 10 to 11, because 4 minus 3, that is 1 hour it will go. So from 10 to 11 it will, this meeting will go on. So this is the way how we need to handle this intervals. So we need to return the minimum number, the room which had maximum number of meeting, and if there are multiple meeting rooms which has same number of meetings held in that meeting room, so we need to return the minimum out of those. So this is how we need to handle the meeting room problem. So how are we going to handle this? So we need to have some kind of data structure which will tackle all these things. So for this let's take a priority queue. So first of all, what comes in our mind is whichever meeting will start at the earliest needs to be allocated the room. Now if a meeting is starting at 10, if I'll allocate if I want to allocate that room, and another meeting which is starting at 5, these are the two meetings that needs to be started. So if some meeting is starting at 5, we will allocate a room to that meeting first, because uh, the meeting that is starting as at 10 will obviously will be late. So why to waste time? So we'll allocate the that meeting room to first. Now this is the logic. So this after this intuition, what comes in our mind, that we need to sort this array on the basis of start interval, because the one who will come first will go to the meeting room first. So we'll sort it on the basis of start meeting room. Now we need to keep track of the end, which meeting is ending the earliest. We need to keep track of that thing. So suppose if we sort this, now we know that a meeting started at 0 will end at 10. Now another meeting comes, which there were two meeting room, so we consumed this meeting room with the interval 0 to 10 meeting. This meeting is going on this in this meeting room. Now another meeting is scheduled at 1 to 5 at 1. So we can see that there is an empty room present. So we'll allocate this 1 to 5 meeting in this meeting room, and the meeting will be ending at 5. So we'll keep 5. Now another meeting comes, is starting at 2 to 7, but we can see that both meeting rooms are full. We cannot allocate this meeting room, so we need to wait till a meeting to end. So which meeting will wait till? We'll wait till the latest, the shortest interval meeting. So this is the 5 which will end first. So this will be ending first. So we need to keep this meeting room at the top. We'll remove this meeting from the meeting room, and we'll allocate this new meeting. So we have to wait till 5. This meeting had to be started at 2, but there was no meeting room, so we waited till 5. At 5, one meeting room became empty, so we'll allocate this meeting room. So 2 to 7 now will start at 5. Instead of starting at 2, it will start at 5. It will go till 5 hours, because 7 minus 2, that is 5. So it will go from 5 to 10. Now 10 will be pushed in our queue. This is at meeting room 0, this is at meeting room 1. Correct? Now 3 to 4, another meeting comes. Now we can see that both meetings are still consumed, so we have to wait till at least 10 hours, 10 o'clock. Suppose 10 o'clock, we need to wait till 10 o'clock, and then only we can start to allocate new meeting room. So we waited till 10. At 10, these both meeting room became empty. So this room also became empty, this room also became empty. So we need to allocate the minimum meeting room, the meeting room which starts at first. So 0, this is the meeting room 0, and this is meeting room 1. So 0. So we will allocate this 3 to 4 at meeting room 0, but the timing will be from 10, start from 10, because we waited till 10. So the difference, 4 minus 3, that is 1. So it will go from 10 to 11. This meeting will go from 10 to 11. So this 10 to 11 will be allocated over here, and in our a new ending will be added in our priority queue, that is 11 with a meeting room of 0. So this is the way we will be handling this question. So it's not very much difficult to understand this question, but it might be a little tricky to code it out, but still not very much tricky. So let's try and code this question and see how we are handling everything. Okay, so we'll keep a priority queue. Uh, pair int comma int will make it uh, a min heap, I would say. So for that, priority queue. This is my priority queue. I'll sort my meetings. Now what I need to do, I need to start the first meeting. I'll keep a time. I'll push in my priority queue. I also have I also need to keep a set which will handle the meetings in sorted order, because we need the smallest meeting room number to to be allocated a meeting at first. So for that we need to sort it. So we'll keep a set which will handle these rooms, available room, maybe AVAL, available room. Meeting room will start from meeting room 0. I'll go till n. AVA available rooms dot. So right now all the rooms are available. We will allocate it a meeting with the first room. So maybe I can even start. Okay, no problem. Let me start my. I'll push my meetings of zero in my priority queue. With allocate this with meeting room 0. Now ending. We need to add the ending of this. Now time will start with meetings of 0 of 0. Will also erase from available room, AVA available rooms dot erase, because we have already used its meeting room 0 in the first meeting. We'll remove that. Now while my priority queue is not empty, while my priority queue is not empty, uh, okay, we need to keep the count. How many are there? So for that, for keeping count, we can keep a map will keep what? Int room. Mm, mm, mm. Maybe room co room count. Another map. This can be another map. This will tell me what. Now the first half is my room number, and the second half is its count, how many time that room is allocated. Okay, and also I'll add it in my map. Wait, maybe I'll add it here. So I'll have and end time, meeting end time will be pq dot top. This is a priority queue. Pq dot top dot first. Maybe I'll make this end time. I'll keep maximum of end time comma. Now if my meeting room is full, how we get to know that meeting room is full? uh, we can check in our priority queue the number of values kept in our priority queue. If it is equals to n is my number of meeting rooms. If it is same, then we can say that okay, this meeting room is full. Total number of meeting rooms has reached. Now we need to empty the meeting room before we allocate a new meeting to that meeting room. Okay. Okay, so priority queue end time we kept maximum. Now now if pq dot priority queue dot size is equals to n, then end time will be updated with maximum of end time, or pq dot, okay, no, and here it will be meetings of I of 1. No, this is the start time. Let me take it time. It will be confusing if I make it end time, because this is not end time actually. This is my time. So if my time is maximum or my meetings of I of 0 is maximum, will be kept in my time. Now if my priority queue has reached to its limit, now we need to remove. So we need to reach to the end time. So not end time, we need to reach to the time which is at the top of the priority queue. So time pq dot top dot first. Now while not pq dot empty and time is greater than or equals to pq dot top first. If this is the case, what we will do is st aval available rooms dot insert pq dot top dot second. I'll remove, add it in my available rooms and pq dot pop. We'll pop it. Now, now what will happen? Now we will. Now we are 100% sure that there is a meeting room available always. So we'll allocate the minimum. So available room is equals to AVAL available rooms dot begin. That is begin. The value at there. Now AVAL available rooms dot erase room. Now this priority queue dot push time plus meetings of I of 1 minus meetings of I of comma with this is the room number. With this I'll also insert in my room map which is room count. I think room count of room plus plus. Okay, meetings of I of 0. Where is this? Meetings of I of 0. I need to iterate to this meeting, right? Picking each meeting. And start it with 1 because 0 is already inserted. Maybe even I should not insert this meeting over here. That will also be one of the part. Okay. Now what we will do is auto IT is equals to room int answer is equals to 0 comma count is equals to 0. Now if IT का second is greater than count, count is equals to IT का second, answer is equals to for this I'll keep map only, don't keep unordered map. That will be not very okay, it'll go infinite. I haven't increased my I. TLE, give me TLE. Out of bound, know that I is lesser than. Okay, so these two cases are running. Let me submit it and see whether we are getting some wrong. Okay, it's saying integer overflow because we kept that time as integer. Let me keep it long. Let's use this test case. Meetings of I, we need to manually make it long. Okay, what happened? I wrote this code, man, don't do this. Okay, if we submit this, okay, it's accepted. Great. So we were able to solve this meeting room 3. Now we can jump to another question, which is odd even jump. So let's just jump to another question, which is odd and even jump. Uh, this is a bit trickier question, I would say. This is not very much easy to understand how we are doing everything, but if we understood, then the solution is not very much difficult for this. The question is more difficult than the solution. What we can see is, let's take an example of 5, 1, 3, 4, and 2. Now what we need to do, we need to do odd and even jump. If we have, the condition says if we have odd number of jump, if we are doing odd jump means at any index we can do any number of jump. Okay, so what I'm saying, if we are doing an odd number of jumps, so at any index we can do even jump or odd jump. We can do even odd jump from here, or we can do even jump from here. But if we did any odd jump from here, then the next jump should be even jump. And if we did any even jump from here, the next jump should be odd jump. Y- Your count, like from how many index, from which index you can reach to the end. So you need to count all those and return. That is what the question is. Now, what the condition for odd jump and what the condition is for even jump. If this is an odd number of jumps, so we can jump from a specific index to another specific index. So like from 0, from 0 we can jump to 3 or 4 or 5, anywhere we can jump. So from the 0 index we can jump to second index. So that means uh, what is the condition of odd jump? So this is suppose I index, and this is the index where we are jumping. So if we have I, so ARR of I should be lesser than or equals to ARR of J if we are doing an odd jump, and ARR of J should be the smallest. This means smallest means among all the smallest possible values, is like if we need to take all the values which are greater than ARRI, and among them we need to find the smallest value and we can jump to that index. That is what it is saying. Just a second. sorry, my camera and mic was off, but still I was explaining the question. Sorry. So, what should I do? Should I come back again? Okay, I'll explain from here only. So we need to do an odd jump. If we are starting from index 3, we need to do an odd jump. So for odd jump, what we have to do is we need to find all the values who all are greater than 3 beyond 3. So we can see only 4 is the value which is greater than 3. So amongst all the values who are greater than 3, we need to find the smallest. So 4 is the only value that is present. So 4 is the smallest here. So we can jump from 3 to 4, an odd jump. And after an odd jump, we need to do an even jump. So for even jump, what we need to do is we need to check all the values which are smaller than 4. This condition says that we need to find all the values which are smaller than 4. So 2 is the value which is smaller than 4. And amongst all the values, which is the largest? So 2 among 2, or if there will be many, pick the largest one and jump to that index. So 2 is the only value. So we pick 2 and we jump to the value 2. So this is what my odd and even jump is. So from 3 also we can jump. So from 1 also we can jump. From 3 also we can jump. So we can increase our count to 2. Let's see from 4 can we jump or not. So if we are starting from 4, we need to do an odd jump first. This is our condition, that we need to do an odd jump first. So if we are doing an odd jump, we can see that for odd jump we need to find all the values which are greater than 4, but we cannot find any value which is greater than 4 which beyond 4, so we cannot jump from 4. And so if we are at 2 now, if we are at 2 second index, we can say that okay, 2 we can jump to 2 only. So the count will increase to 3. So total count that we can see is 3. So from index 1 we can jump, from index 2 we can jump, and from index 4 we are already at the end, so we are counting that also, so we can jump to that also. So this is what our resultant will be, 3. If you are not getting it, you can tell me, I'll explain it again, or even you can watch the video. You can go back and watch the video. Now let's just code this out. So for this, for handling this part, we'll keep a map. Again, what we did in interval part, in range module, something like that only we are doing. Now we'll keep a vector also to store the odd jump and the even jump. So vector int odd jump, for odd it'll be of same ARR of size, uh, initialized with 0. Now even jump ARR of dot size initialized with 0. Now odd jump will start from backward, will not start from start, will start from end, and then we'll go one step backward, because the end value we know, we we 100% are sure that the end value contains, we can jump to that end value, because right, correct, because that is the index we need to reach, and if we are at that index, we can jump to that index. So that will be much more easier if let's keep a size of ARR dot size order of n minus 1 will be updated with 1 odd jump, and even jump of n minus 1 will also be updated with 1. and will also keep it in my map the last value. So it's ARR of n minus 1. No, not ARR of n minus 1. Here it will be ARR of n minus 1 will be updated with n minus 1. With that index, the value will be updated with that index. Now I will start with n minus 2. I'll go till 0 and I'll reduce the value. Now if now I need to find a value, a value which is equals to or lower than. Now I need to find a value which is for odd jump. For odd jump, what was the condition? We need to find all the values which are greater than ARRI. So for all the values which are greater than ARRI, we can a upper bound from map okay, from map dot, maybe let's name it high. So we need to find a map dot upper bound of this ARR of I, and low, we need a low also. We for even jump, this is for even jump we need to find values, all the values which are lower than that value. So the same thing, it will be same, we'll go with the upper bound of ARR of I. Okay, for the values for high, we need to find all the values which are equal to that value or greater than that value. That that can be handled with lower bound also. Lower bound will go to that index if it is present, if the value is present, or it will go to the next value. And for all the values which are smaller than this, I'll go to an upper bound and then move to a previous. Let's make this as lower bound. Lower bound. Now we are doing an odd jump which is higher values. So if my high is not equals to map.end, that means we are doing an odd jump. So odd jump of I will be equals to even jump of higher second. Means if we are jumping from here or doing an odd jump, so wherever I am reaching, I need to find the even jump from there. If we can do an even jump from there or not. If we can do that, we'll update my odd jump also. Now if my low, for low, what we are doing, we are doing an even jump, all the values which are smaller than ARR of I. So which are greater than or equal to or smaller, if it is smaller than, if it is not equals to map dot begin, if low is not equals to map dot begin. Then even jump of I will be updated to odd jump of previous of low. A second. And now my resultant will be added with odd jump. Because we need to start from odd jump, we need to add odd jump of I in my resultant, and finally we'll return my result. I need to initialize my resultant also. Int result will be initialized with 1 because of the last index. Okay. Okay, let's see what mistake are we doing. Oh, we didn't add in our map of map of ARR of I is equals to I, and we are starting from n minus 1. No, should start from n minus 2. Correct. Let's submit it and see if we are able to. Oh, great. So the time complexity for this will obviously go n log n, because we are keeping a map, sorted map. So this will be on n log n. Great. So we also solved odd even jump. We solved meeting rooms 3, and we solved range module. These are the 3 hard questions that we solved. You only need to solve this find MK average. And so now what I will do is I will uh, try and solve all the all the green medium questions available here, and easy questions in the next 50 minutes, and then we'll jump to 1 year questions of Google, all the Google questions of 1 year. This way we can solve more. Okay, so let's have a break for 10 minutes and then we can start again. Hello everyone, I'm back. Let's solve few more questions today. Okay, before solving question, I want to say that we have our special friend, which is Utkrish over here. So maybe I'll introduce Utkrish to you all. So hi Utkrish, how's everything going? Hello, Krish, can you hear me? I think he's not available. Maybe he was here. Okay, whenever he will be here, we'll have a talk. So I just want to tell you that he is coding in Java questions. He is basically solving some DSA questions based on uh, union and find and BFS and DFS, I suppose. So if you want to join and if you want to learn union and find, and so you can use this URL, this meet link. I'll paste it in my chat also. You can join there. You can learn with him, and we all can code together. Okay, great. So let's start and let's learn. We already have crossed a few minutes. Let's not waste any more time. Let's start with this return node or delete node, minimum area rectangle, earliest moment we become friends, and done. 1, 2, 3, 4. These are the 4 good questions. Okay, so logger rate limiter. This is a premium question. It's not very much hard, I would say, but let's see. Let's remove this. Okay, so it says design a logger system that receives a stream of messages along with their timestamps. Each unique message should only be printed at most every 10 seconds. That is, a message printed at timestamp t will prevent other identical messages from being printed until the timestamp t plus 10. All messages will come in chronological order. Several messages may arrive at the same timestamp. Implement the logger class. Should print message time at this timestamp. This message return true if the message should be printed in the given timestamp. Otherwise, return false. Okay, let's see an example and see how we can solve this. Now, should print message. So, should print message. It's given at timestamp 1. This message is going to be printed. Let's write it down together so we can understand. At timestamp 1, foo message will be printed. Now this message will be elapsed or will be finished at time 11, right? 1 started at 1, I'll add 10 seconds more, it'll finish at 11, something like this. Okay, now again should print a message comes 2 with a bar, 2 with a bar, 2, so bar is not there, so at time 2 it'll finish at 12 and bar. Now foo again comes at time 3, so we can print this foo, we can print this bar, but this foo will not be printed because its timestamp is 11, and before 11 we cannot print foo again, so that's why it's false. Correct. Now 8 bar, 8 bar will also be not be printed because its timestamp is 12 and it is coming at 8, so not printed. Foo at 10, 10 also will not be printed, it will only be empty at 11, so it will again return false. And at 11 this foo can be printed, and this at 11 plus 10 will be 21. So the next timing will be 21. Something like that we need to print. It's not very much hard, I would say. It's kind of very much easy. We'll keep a should print. We'll keep a unordered map of string corresponding integer log. Now timestamp and message. So at this timestamp this message can can be printed or not. So we need to return if we need to find whether this message is present or not. If log dot find message is not equals to log dot end, that means this message is present. So we still need to check if the message, if log of message value is lesser than, sorry, is greater than timestamp, then return false. Else before returning true, I'll do what log of, I mean SAG log of message plus is equals to 10. So I'll add a 10 to it and then I'll return true. Or even log of message is equals to will be time stm stamp plus 10 and return true. If we submit this, so it's accepted. Great. So it will be of O of n time complexity, not more than that. So it was very easy question. O time complexity is constant because we are inserting. So should print message is going till 10 to the power 4 cos. So O of 10 to the power 4, that is O of n time complexity will be there. Now the next question is delete node and return forest. Actually, I've already solved this question before recently, so I'll explain this question and then I'll move to the next question. We have we have been given these nodes to be deleted from this tree, and after deleting 3 we need to return all the root node that is after being disconnected. So if we can see this node 1, 2, 3, 4, 5, 6 and 7. So in this case what we'll do, if we are removing this 3, so this 3 will be removed, and this 6 and 7 will be a new root. This and this will be a new root, and again 5 is removed, this 5 will be removed, there will be no new root. So in this case we'll return 1, this will return this tree, will return this tree, one separate tree, and this separate tree, and this separate tree. So this is what we will do. So how to approach this question? So in order to approach this question, what we need to do, we need to backtrack from the back. So suppose we reached here, we are going back, we are we are doing a backtrack from here. We check that this node is, we want to delete it or not, if it is present in to delete or not. If it is present in to delete or not, will return false, will return false from here, will return false from here. We check this 3 needs to be deleted or not, so this 3 can be deleted. So if we want to delete this 3, what we will do, we will delete, we will check whether it is present in to delete. Yes, it is present, so we'll push its left and right child to our root node, and we will return true from here. If it got a true from right side, that means we need to disconnect this part from right, because this node need to be deleted. So if we are deleting this node, this its right will be null. Similarly 5 it needs to be deleted, it will return true, and its right will, 2's right will be null. So we are going something like that. So this is the way we are approaching this question. It's not very much difficult, but at first if you're solving it for the first time, it might be a little complex for you, but not very much. You can see we called a solve tree. We created an unordered set to keep the to delete one to in order to find it in O of one time. We called this solve tree method. What we'll do, it'll, if we found the root as null, we'll return false. We'll call this solve tree from left, we'll call this solve tree from right. If from anywhere we got true, we'll make its left or right null. And if the current node value is present in our to delete node, then we will do, if its left is present, if it is its right is present, we'll push it in my resultant and we'll return true from here, else we'll return false. So this is what the solution is: delete node and return forest. So it's not very much difficult. If you want, I can explain you again, but it's fine. Okay, so this is the question. uh, I haven't solved it for a long time. Let's solve this question, and then we will solve these two questions, and then we can jump to 1 hour. Okay, so the question says is, you are given an array of points xy plane points where points of I is equals to xi yi. Return the minimum area of rectangle formed from these points with sides parallel to x and y axis. If there is not any such rectangle, return 0. So we need to form a rectangle. So for forming a rectangle which is even parallel to x-axis and y-axis, so after saying that it should be parallel to x and y-axis, it gave me an intuition. I don't know what is the spelling of intuition, but intuition. We got an intuition. The intuition is what? We know if we find 2 points, we can generate 2 other points. So for example, and that 2 point has to be diagonal. Now, for example, if I say we find we have 2 points, a point is at here and another point is at here. So we know the coordinates of these 2 points. The coordinate will be 4 comma 3 for this point, and the coordinate for this is 6 comma 6 for this point. Now if we know these two diagonal points, we can create the other 2 points. That's for 100% sure. We know that. How we will be able to create? We know the x-axis for this and the y-axis for this. So we'll take x for this point and x for this point, and we'll create a new point that is 4 comma 6, which will be here. This is our new point. Now the second we will take is, no, sorry, not x of this, we'll take y of this because we want the length. So we'll take x of this and y of this. Now we want to create this, so then we will take x of this and y of this. So this will be another point here, which is 6 comma 3. Sorry, here it will be here. Another point which is 6 comma 3, which is here. So we can see that this rectangle will always be parallel to x and y axis. This is the intuition. If it would have given something else, then it might be a problem, but we know that if we found 2 points which are diagonal to each other, we will be able to find the other 2 points, and then we can find the area. So this way we will encounter, if we go to all the diagonal points and we find something like this, so what will happen? If we have x1 y1 x2 y2, these are the points. So we'll do what? We'll do x1 y2 and we'll do x2 y1. These will be two new points that will be generated from these points. So let's just solve this question and see what other things we can do. We have been given 500 points, so we can go for n square approach also. So we have points size equals to 0 as points dot size plus I. So for j also will start from 0 0. Mm, can we even start from j plus 1, because we would have already handled those points. Now I need to keep all these points because we need to find. So case in this case these 2 points, that is 6 comma 3 and 4 comma 6, should be present in our total points. Then only we'll be able to find the rectangle. If it is not present, then we will not do. So we need to keep this in somewhere so that we will be able to track it down. So we can keep it in set of pair, maybe pair. I'll keep pair of st. What I'll do, I'll iterate over the points. St dot insert points of I of 0. So at one position we can have multiple points at the same value. So if we find two values which are at the same location, so we cannot do that. If I is equals to j, that means it's the same point. I'm repeating again, so I'll continue with that. With this, I don't want to create. Now my x1 is points of I of 0, point y1 is equals to points of I of 1, int x2 is equals to points j of 0, int y2 is equals to point j of 1. So these are the 4 points that we picked. Now we need to create 4 more points, x1 y1 x2 y2. Now we need to create x3 y3 and x4 y4. We need to check first in our map if they are present or not. Now if st dot find x1 y2 is not equals to st dot end, that means this is present, and we need to check one more thing, st dot find x2 comma y1. If not equals to st dot end, if these two values are not present in is present in our set, that means we can say that we can form a rectangle. So what do we need to return? We need to return the area of the rectangle. How do we find the area of the rectangle? So area is equals to minimum of area comma, if there is not any such rectangle, return 0. Area, we need to find the minimum. So area is equals to minimum of area, or length will be what, x2 minus x1, x2 minus x1, x2 minus x1 into y2 2 minus y1. We need to find the absolute of it. We don't want negative, so make it absolute even if it is negative. And now whosoever is the maximum will be kept in our area. Now we'll return my area. We'll keep a variable. What is the return type? Is it long? No. And area is equals to mm, if area is equals to int max. It's if it stays int max, I'll return 0, or else I'll return area. Let's see. hmm what we can do, if find area is not equals to 0, if it should not be equals to 0, that's if multiple points are at the same place, that doesn't mean we need to return the answer. Let's submit it and see if we are thinking in a correct way or not. Ah, great. So we are thinking in a correct way. The time complexity went n square. Can we reduce the time complexity? Can we? Can we do something with the help of map? We need to find the 2 points. N square n to the power 1.5 hash map plus sect intersection. What is this? N 1.5 n to the power 1.5. I don't think we can reduce it further. Even we can reduce it, we can keep some map to store the previous value, that if the same two values is encountered again, we won't be handling that part. But that's not even going to reduce my time complexity to very much, so it's fine. So now let's solve this question. The earliest moment when everyone became friends. So the question says there are n people in a social group labeled from 0 to n minus 1. You are given an array logs where logs of I is equals to timestamp I xi yi indicate that xi yi will be friends at the say at the timestamp I. Okay, it says that xi y I will be friends at the timestamp I. Find friendship, it's symmetric. That means if A is friend B and B is a friend of A, also person A is acquainted with a person B if A is friend of B, or A is friend of acquainted B. Okay, this means simple. I would say if A is friend of B and B is friend of C, and then automatically A will become friend of C and C will become friend of A. So, uh, something X I and Y. So C became friend of A become friend of C. It's mutual from both sides. A become friend of B, B becomes friend of A. So it's kind of mutual approach that we are thinking over here. Return the earliest time for which every person became acquainted with every other person. If there is no such earliest time, return -1. So I need to return the time, earliest time when everyone becomes friend. So let's take an example and understand how what are we doing. So the one thing that hit in my mind right now exactly is we need to find the earliest time for which every person needs to be acquainted with every other person. So earliest time means I need the latest time or the lesser time. So we need to sort it on the basis of time. That's the one thing that came in my mind at the first. I haven't checked it. Maybe it'll be wrong, but this is what I came in my mind. Okay, fine. So what we'll do is we will start solving this. So 0 to 1 became friend at the timestamp of this 201 901 01, 201 901 01. 3 to 3 became friend of 4. 3 to 4 became friend at 201 901 04. 2 became friend of 3. 2 became friend of 3 at the timestamp of 201 901 07. 1 became friend of 5. And this means 2 is something like this: 2 3 4 015 at timestamp 201 90211. Now 2 became friend of 4. It's already there. 3 became friend of 4, 2 became friend of 3. 3 became friend of 4, 2 became friend of 3, 2 became friend of 4. Obviously. Now 0 became friend of 3. Now the 0 become friend of 3 means this is the time where everyone became friend. So 201 90301. This is the earliest time when all became friends together. So what we can see over here is we need to make a group, kind of union of all the values, some union and find approach. Maybe this can work. We can work with union and find approach, and we'll sort it with on the basis of time. Start earliest time, and then at the moment when everyone become friends, that is the moment where I'll stop. Correct. Let's try and code. Firstly, let's create a data structure for union and find. So class union find, this is my data structure. I will have public methods, maybe let's keep it private method, doesn't matter. The first thing will return find will return what? Find will return the parent. So we will have a value here. What we will do, if parent of val is equals to val, will return val. Now parent of val will be updated with find of val. I'm not going to tell the union and find approach because it'll take a lot more time to solve this question. If I'm going to explain the union and find how we are handling the union and find thing. So if you want, you can learn the union and find question on your own by yourself, and then you can approach this question. So it'll not be very much difficult if you know union and find how it works, but if you don't know, it might be a difficulty. Okay, so this is my find. Now we have union will do nothing, union will just do union. We have union of x comma union of y. So even we can do directly, or we want rank to be kept, we can keep rank also. We have a parent. This rank will always keep it long because it always. Now parent of x x parent is equals to find x, y parent is equals to find y. And now if rank of x parent is greater than rank of y parent, if this is the case, if x parent is greater than y parent, that means parent of y else, and will also add rank of x parent will increase, plus is equals to rank of y parent, else parent of x parent is equals to y parent, and rank of y rank of x parent. So this will do our job. Okay, make it, these methods will be public and these variables will be private to this, or even okay, union and find, union and find is equals to new union and find, and make it uf. It now uf dot parent dot resize. There are total of n friends, so 6. It starts from 0. Okay, so parent dot resize n, and union and find dot parent dot resize, sorry, rank dot rank dot resize it to n, and initially everyone's rank will be 1. uf of parent of I is equals to I. Initially they will be their own parent. Now what we'll do, we'll sort this logs on the basis of just a second. Okay, so we sorted the logs, the first value basis on the first value. Now for entire, how many values do we have? N will be maximum of 100. Now I is equals to 0. I is lesser than logs dot. You can even go for a square method. So after combining each friends, we'll check with n whether it matched with n or not, whether it matched with this or not, whether it matched. So something like that we can approach. Maybe that will help. So in this case what we will do, we'll find parent we need to find the parent. If their parents are same, don't do anything. If not, then do union. Parent of logs logs of I of 1. Parents of logs of I of 1
will be uf dot find parent of logs of I of 1. Int parent 2 will be uf dot find logs of I of 2. Now if p1 is not equals to p2, that means the parents are not same, so we'll do uf dot underscore union of p1 comma p2, combine these two, and we can increase a count, we can keep a count if the parents are not same. uh, if we keep a count, we increase it by 2, will it make sense? No, it will not make sense. Now after doing union, we need to check if all the values are same or not. Pick a value and check whether all the values are same or not. If all the values are same in my parent, then we are good to go. So let me, for int I not j is equals to 0, j is lesser than union find dot even I can take n plus plus j. Start with 1 if it is same, if it is same. Now if uf dot parent of j all friends is equals to true is not equals to uf dot parent of j minus 1, all friends will be set to false. Now if all friends are still equals to true, that means I'll return this timestamp of 0. Else after doing everything, if I'll return -1. Okay, so we created this union and find and union method. We created a parent, we created a rank. Let me just run what are the errors we need to handle. Non-void function does not return a value in all controlled path. Okay, sorry, I need to return. Not candidate constructor not viable, no other conversion. So the default constructor is always there, right? Why do we need to create a default constructor? Maybe uh, we can do all these things over there only. Maybe I'll create a parameter default constructor as well as a parameterized constructor union and find, where I'll get a value n, and I'll make it I'll update my parent, I'll update my rank, I'll update my parent with I. With this default constructor, I'll pass n over here. Now it's saying union and find star dot to union and find. Why it is coming to a pointer? Parent is a private. It should. I'm accessing outside. Mhm. What wrong are we doing? Can we check whether our union parent and rank was initialized correct or not? We have n plus you have dot parent of I something. Let's see if the output is coming or not. So it's coming. Even for rank, all the values are perfect. So the values are initialized, everything is done. I'm iterating logs. Everyone will have 0, 1, 2. I sorted this log dot size parent union find I of 1, I of 2. I am not going out of bound. Why it is overflowing? Parent of val is equals to val return val or parent of val. Does otherwise parent of val will be updated with find of val. Correct now. P1, P2 and L. So for first 01, parents were 01. So we did union for parent of 01. Now 3 4, the parent of 3 4 is 3 4. Now 2 3. Mm-hmm. Where in union is it? In union we are doing, it's saying in val. That is when 2 3 is coming. It's saying parent of val is equals to val. You have taught parent of P2. After doing union, I need to check what happened. So parent of 01 became 1. Parent of 3 4 became 4. Now 2 3. So 3's parent is 4, 2's parent is 2. Oh, so in this case, if we remove this rank, let's remove this rank. We only do one operation. What is happening? I'm doing union. Okay, so we have a problem here. What is it related to union and find? Union means if someone's parent is him itself. If its count is more than one. If parent of I is equals to parent of j. If its count is more than one, count is 0. Friends count. If you have dot parent of I started with 1. Let me start with 0. Parent of j is equals to j. Friend counts plus plus. Now if friend count is lesser than equals to 1, has written -1. Where is my C out? We are doing C out. Where? Okay. If we submit this, just see if it is accepted or not. Okay, great. It is accepted. Even one more thing that I removed was rank. Let me check if it is working with rank also. Okay, till now it's working. Great. So it is working with rank also. So what we did is we created a separate data structure for union and find. Now I got to know that parent and rank cannot be kept in private. We need to keep it public because else we'll have to create a function over inside this class only for checking all those things. So for now I kept it public. Elsewhere this method we need to keep it inside that. So it's great. Nice. It's a nice question and we were able to solve it. So let's take a break. We solved mostly all the green questions of past 6 months except this finding MK average. I think I'll solve this question after some time and then we can go to 1 year questions. Now let's take a break for 10 minutes and then we'll solve more questions.
I'm back. So let's solve some more lead code questions. So after this, we'll take a break, a long break for lunch. Okay. So which question should we go for? Let's pick some questions from 1 year. Maybe we'll go from backward. This difference between two objects, it's what should I say, Java, TypeScript and JavaScript question. So I won't be solving this question. Maximum strictly increasing cell in a matrix. Odd even jump we already solved. Parallel courses is also a good question. Earliest moment we solved. Right now minimum area rectangle we solved it. Detonate maximum bombs. Let's solve this one. Count k sequence. Meeting room already solved. This already solved, and this. So okay, this time we need to solve these two questions. These two hard questions are really important, I would say. We need to solve these two hard questions. Okay. Okay, so we'll be solving this question. Detonate the maximum bombs. So we are given a range of bombs defined as area where it effect can be felt. The area is the shape of circle with the center as the location of the bomb. The bomb are represented by 0 index 2D integer array bombs. The bomb is xi, yi and ri. Denote the x coordinate and the y coordinate of the location of the ith bomb. You may choose to detonate a single bomb. When the bomb is detonated, it will detonate all bombs that lie in its range. These bombs will further detonate the bomb that lie in their range. Return the maximum number of bombs that can be detonated if you are allowed to detonate only one bomb. If we have to detonate only one bomb, I need to figure it out how. Okay, so the question is, let's take this as an example. So this example says that we have been given a bomb which is positioned at 1 comma 2 and its radius it can go is till 3. We have another bomb at 2 comma 3. Its radius can go it has a radius of 1. 3 comma 4 has a radius of 2. 4 comma 5 has a radius of 3. 5 comma 6 has a radius of 4. Now I need to detonate only one bomb. Whichever bomb will be detonated, the maximum number of bomb that we need to will be detonated after detonating that one bomb. We need to return that.
Okay. So I need to know, I need to figure out from this point, from this bomb, which all bomb I can detonate. Means from this bomb I can go to those bombs for detonating. Correct. If we sort this bomb on the basis of x-axis, is that going to help me? Yeah, we can sort this on the basis of x-axis and make a graph plot, something like that. So we'll create a vector int bums. Let me create a map. This is my graph. if I go if I can go to the another position, how can we know, how do we know that we are going to the another position? We'll check from start if I and j are same. Okay, so int, I don't need to sort also because it will even go. Now if I is equals to j, I'll simply continue. If not, then I need to find whether uh, the distance between the point is if lesser than or equals to the radius, then we can say that if I detonate this bomb, I'll be able to detonate that bomb also. So what I will do is I'll find a distance. How to find a distance between 2 points? X1 y1 and x2 y2. x2 x2 minus x1 whole square plus y2 minus y1 whole square root over. This will do what? This will give me the distance between 2 points. So it'll be a double of distance is equals to sqrt square root of, let me take x1 bomb of I of 0 bomb of j of 0 int radius is equals to bomb of I of 0 1 2. square root of I need to find the absolute value of x2 minus x1 x2 minus x1 into x2 minus x1. Sorry, whole absolute. y2 minus y1 into y2 minus y1. It will give me the distance. Now if the distance between the radius is lesser than or even equals to r, I can go from here to there. So g of I dot push back j. From I can go to j. So this way I created a graph. So I created a graph. Now now it's very much simple. I need to make a find int result is equals to 0. One bomb will be detonated. So for int I is equals to 0, I is lesser than bomb dot size plus I. So result will be equals to maximum of result comma and answer is equals to 0. I'll return do a DFS from this position. I'll give G also and I'll pass answer also. Source, I have an ordered map and comma. Okay, I need to handle visited also. So for that I need to keep a vector int visited if visited of src is equals to 1. That means we have already visited, else we haven't visited, then I'll increase. Now my for loop will be is equals to 0 I is lesser than g of src dot. So dfs will be called with g of src of I. Map will be visited will also go and answer will also go. I need to create a visited of n of size initialized with 0. Bomb line number 18. Mhm. GFI dot pushback J from here. If I start from 1, I can go to 0 also. So here to here and here to here. So 0 में push नहीं होगा, 1 but 1 में push होगा 0. So 1 answer plus plus 1. I'll call it with 0. 0 is also not. Yes, for everything we are uh, I don't even need this absolute value. I0, I1, J0, J1. I created this only as a graph. Correct. Xy, x1, y1, x minus x1, x minus x1, y minus y1, all are double. If c distance is lesser than or equals to, so if distance is lesser than or equals to r, everything is double. That also won't affect. The past count visited is true nahi. I marked this as visited and creates the counter. My DFS for this, done 0 visited is equals to 1 count. This is what I did. It will go whatever it will return. If already visited, I'll add it with my count. What mistake are we doing? It's unordered map of int of vector. Correct, correct. Hey, bombs of I of 3? Where is I of 3, man? From where? I 0 0 of 0 1 2. Ah, okay. This should be my y1. This should be my x2, and this should be my y2. Now correct. It's accepted. Good. So detonate maximum bombs is also completed. The height of a binary tree. This was a good question. Good question, I would say. And this is what we needed to do. Height of binary tree after subtree removal queries. You are given a root of a binary tree with n nodes. Each node is assigned a unique value from 1 to n. You are also given an array queries of size m. You have to perform m independent queries on the tree, where the ith query you do the following. Remove the subtree rooted at the node with the value of queries of I from the tree. It is guaranteed that queries of I will not be equal to the value of the root. Return the answer of size m. Answer is the height of the tree after performing ith query. So let's take this example. In this example, it's saying that after removing 3, what is the maximum height? So maximum height is still 1, 2 and 3. After removing 2 from here, what is the maximum height? That is 1 and 2. After removing 4, what is the maximum height? That is 1, 2 and 3. After removing 8, what is the maximum height? If I remove this whole subtree, what is the maximum height? 1, 2. So in this case, will what I will do is will handle this with pre and post queries. So this height will be 1, this height will be 2, this height will be 3, this height will be 3. Now the maximum height that we found will go, this height will also be 3. We know left height is 3, 3. 3, 3 and 3. So the values will be unique. All the values in the tree are unique. If I remove this, that 3, 3 is the highest. Okay, this is spray, and if I do the same with post, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3. Okay, so this is a pre and post we are solving. Pre pre will be uh, mm, mm. So what is the highest total number of node? N is 10 to the power 5. So instead of creating a a vector of pre of that size, because we don't know how many nodes are there, we can keep a map for this. That will help me in reducing the size. Unordered map. So its key will be node and value will be so its key will be node, its value will be val val value will be maximum length of a branch. So branch branch to its pre and post. Let's try. let's call a pre-order where I'll pass this root and this pre together, and a variable which will start at 0. mm, let's mm, pre-order where we have a tree node root, we have an ordered map of int comma int, and we have a int maxval. Now if not, it will be 1. mm. I'll start with 1 level. Now pre of max, no, pre of root ka val is equals to max level is equals to correct. We'll pass it 0 only. Max level is equals to maximum of max level comma level, and I'll call pre-order with root left first, pre as it is, max level as it is. This will be passed by address level +1. Pre-order root का right, pre max level +1. I can do the same. We have to do the same thing for post also. So instead of pre, this will be post post order, post order, post order. So instead of starting from left, we'll start from right and then we'll go to left, and the rest of the things will remain as it is. So we'll pass post order call row post order, we'll pass root, we'll pass this post 0 and 0. Now we need to create int resultant. We are given only root. We need to find the total number of nodes. With n nodes, how we know there are n nodes? We are also given an array of size. So the result will be directly of queries dot size. No, queries queries dot size. Do we have to initialize it? It will be automatically initialized now. For int I is equal to 0, I is less than queries dot size plus I. Now if result of I will be equals to maximum of pre of queries of I, comma post of QUE queries of I, return result. Where is int height is equals to 0, height is equals to 0, pass height, pass height. Nice. So it was a pre-order and post-order traversal tree queries. We kept it a map. Earlier, what did I do? I solved it earlier also. At that time we kept it left max and right max as we were resizing it with as that value, but it's better to keep an unordered map that we don't have to initialize it so much. This is good. So we were able to solve this 8 minute. Ajat, Ajay, हाँ. So we solved it till here. All are solved. We need to solve this. So let's keep a note. Let's create a note, and in that note we'll keep track of how many solved, how many we need to solve. How do we do that? So let's take a note for 6 months. For 6 months. What are the question that we left? Let's sort it on the basis of 6 months. There was one question that we didn't solve, that is find MK average. So we didn't solve. Can we add a bulleted point over here? Bullet bulleted point 6 month finding MK average, finding MK average. Finding MK average. This is the only thing left for 1 year. What is the question that we have not yet completed? So the question is still finding MK average. We didn't solve count K subsequences of a string with maximum beauty, earliest parallel, done, and one more, maximum strictly increasing cell in matrix. STRs. Strictly increasing cell in a matrix, because this question I'm not picking because this is a JavaScript and TypeScript question. So let's go for 2 year. There'll be a lot of questions that one race car. Stock price fluctuation we haven't solved. Stock. Stock price fluctuation, my calendar solved. Find leaves solved. Delete node solved. Solved. Direction solved. Finding MK average again. Finding MK average. Okay, there are lots of questions that we haven't solved in 2 years, I would say. We need to solve more questions. Shortest path in the grid with obstacle elimination. We haven't solved shortest path in a grid with obstacles. Can you copy and paste? Amount of area painted each day. Odd even jump done. Maximum strictly increasing cell in a matrix. Maximum number of visible points. Maximum number. Detect square sum of prefix scores. Sum of prefix scores of string. Count k subsequences with maximum beauty. Longest line of executive one matrix. RLE iterator. Number of good paths. Maximum and subarray. Remove all ones with row. Okay, this was a question I solved yesterday, but it was like very weird question. Very weird. No problem. Meeting rooms 2 and find and replace in string. Meeting rooms 2 I've already solved. I'll solve it again. Weird. So there are lots of questions that I need to solve. For second year, we haven't solved. For 6 month, I think only one. For 1 year, if I'll solve this, I'll be able to solve these two also. And from 2 year, I can only remove these 3 questions. I still have a lot more questions to go. Okay, no problem. I guess I'll take a long break now because I'm going for lunch. And then when we'll come back, we'll solve few more questions. I think I'll go for maybe the unapproached question, the question that I haven't approached. Let me increase. 60 minutes. I'll be back in an hour. Hello, everyone. I'm back. Okay, so let's start with some new, fresh coding challenges, coding questions. Okay, which one should I go for first? Out of these three, which one? One, two, three. Let's go for race car. Okay, where is our race car? So the frequency is very high. Now, how many times? Three times from past 1 year, three times. This question has been asked. Google. Okay, so whosoever is preparing for Google, I would suggest continue preparing with me. Okay, so this question says that your car starts at position 0 and speed of +1 on an infinite number line. Your car can go into negative positions. Okay, my position is at 0, my speed is +1, and the number line is infinite. You can go into negative positions. Your car drives automatically according to a sequence of instructions A and accelerate. That will be accelerate and R to reverse. When you get an instruction of A, your car does the following. I'll add the speed into my position. Whatever speed I have, the speed is +1 will be added to my position, and the speed will be multiplied with 2. When you go to when you get an instruction R, your car does the following. If your speed is positive, then speed will become -1, otherwise speed will become 1. Your position stays the same. Okay, if I am reversing, my speed will reduce, my position will stay the same. For example, after commands AAR, your car goes to position AA and R will remain as it is, and your speed goes to 1 2 4 and then -1 for R. Given a target position target, return the length of the shortest sequence of instructions to get there. Okay. I need to return the shortest sequence to reach there. So for example, if I try run this target, my my target is 3. Now this is my position where my car is standing at the position. So my car is at a position 0. My speed is this is my position and this is my speed. Speed is +1. Now my target is 1, 2 and 3. This is my target. Now what will happen if we do an A, if we press an accelerator, and my position will shift here. My position will go here. My speed will be multiplied by 2. So now my speed is 2. Now if I press A again, so 1 plus 2, that is 3. So my position will be at this target. And if it goes beyond, I'll have to reverse. So what can we do in this? We know even my target can be negative also, is it? No, my target is 1 to 10 to the power 4. My car can go to negative. The same thing happens if my car is at a negative position. Suppose AA, my car reaches over here. I put a reverse over here. So my speed turns out to be -1. Earlier my speed was 4, now it turned to -1. Now this will be added to my position. So this will be added to my position. And my target will be 2. Now the speed will again multiply by 2, so the speed will be 2 again. Now 2 minus 2, so it will go in reverse. Hmm. Hmm. So what I can see, I can call this. I can call this. If my target is still greater, I can call this. If my target is still greater, I can do this again. If it goes beyond, I need to reverse the car. If it is going beyond, I need to reverse the car. See, if my car goes beyond this position, then I know that I should not go any further. I'll have to reverse my car. Mm, so, and if we are below that, I will do it. is one thing. If it is more than, if it goes more than, then I do not have to return from there. Okay, so in this case what we can do is, mm, 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 we know this is my target. We can at max go closer to this target. We can go at two places, either the closest one here, or I can go beyond if it does not reach my target. So my target is, suppose 6. Let's make this, this is my position, 1 2 3 4 5 and 6. This is my target. Now this is my position and this is my speed. Position is 0, speed is 1. What can be the possibility? I go here, my speed increased to 2. I add this, I go to position 3, my speed is 4. I go to position, so it is going twice. So next time speed will be 8, then 16, then 32, then 64. Speed is going in an increasing manner. Position from 0 to 1, 3. 3 plus 4, that is 7. That is my position now. 7 plus 8, that is 15. 15 plus 31, 63. So my position is shifting from 0 1 3 7, means 2 to the power n minus 1. It's kind of, if we know position 0 1 2 3, 2 to the power 3 minus 1, that is 7. We can reach at 7. If we know n, how to find n? The distance between here till here. Mhm. Log 25 base 2. 2 to the power something. So 2 to the power n. How many? 1 2 4 8. Like 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So 2 to the power n is equals to 6. If I take log both side, n log 2 is equals to 6 log 6. 2 log 2, n is equals to log of 6 base 2. Now log of 6 is what? base 2 log 6 base 2. Base is 2 log of 6. Log of 6 base 2 is approximately 2.58. 2.58 means if we take a power of 2 to the power 2 2 to the power 2 minus 1, that is 3. 3 is the closest that we go from left, because if we take 2 to the power 3 minus 1, it will be 7, which goes beyond my 6. So I need to find this log, um, which C++ STL method helps in finding log. C++ STL for log. What is B here? It's log 2D. 2D. It should be. Okay. So if we are going beyond, we are reducing our speed to -1. We are changing our speed to -1. And if we are going closest, the two possibility, if we go to the closest one, that is 3, we went to 3, or we can go to 7. We went to these position. Now here I'll have to reverse my car and then reverse it again to move further. I don't want to go this way one step and then go. I will reverse it and then reverse it, and then I'll go forward with one step at a time. But here I'll reverse it. Mm. Whosoever gives me minimum will be my answer. Okay. So if we try to make a solution, my target is 6. If I go to the 2 to the power n minus 1, 1 solve will be minus 1 steps plus 1 step for reversing plus 1 step for reverse back again. Means accelerate, 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 reverse, reverse. Suppose accelerate, accelerate, reverse and reverse. Third will be accelerate, accelerate, accelerate and reverse. So this will be nullified 2 to the power n plus 1, and the second one will be 2 to the power n plus 1 minus 1 will give me this position. Now this position is I need to reverse once again, so I'll add plus 1. So 2 to the power n plus 1 plus 1, that is 0, and the speed will be changed. We'll call solve again. With rest. So for minus 1, how are we handling? If it goes beyond, it will only go beyond once, not more than that. That I will subtract. I need to know from where are we coming. That also one of the thing. Like if we try, let this be here. This will be my target. Int n 2 to the power n. N will be so log of 6 base 2 will give me n. So log 2 target. So what is the value? Closest is equals to 2 to the power n minus 1, and beyond will be is equals to power of 2 to the power n plus 1. Now minimum of answer is equals to answer plus minimum of these two. So the new value is my target. If we are doing this, so the total steps will be, I'm doing n steps plus reverse and reverse back again plus solve से जो आया closest and plus one step, plus one. What? They both are coming same. Why? Beyond. If target is equals to 0. Okay, it is a little confusing. Let for the input 5, we can reach with the steps with only 7 steps. A R A R A A, because we can step back. Let's say n is the length of the target. In binary we have 2 to the power n minus 1 is lesser than equals to target. We have two strategies here. Go pass our target, stop and turn back. Go as far as possible before pass target, stop and turn back. Okay, stop and turn back. I first think the DP way should be No, I don't want this. I want recursive solution for this. Also, going past next is not optimal because we need to spend one acceleration to go past next, and only 1 hour is also needed to reverse, which we'll do eventually in order to go back target. So the best case scenario will only be able to match the best result, not go under it. No, they are creating 2D array. I will go to 2D array, but I need the recursive solution first. Because recursion is always the intuition. Move close to that point and then start. Let me understand this in a better way. And some YouTube solution. It's like went 2 steps n, and then we are going I steps backward. So we are adding I steps backward for backward, one step for reversing, and then the same function. Call again. So this time will my target is greater, so t minus 2 to the power n minus 1, obviously, plus 2 to the power n minus 1 will reach here, plus 2 to the power I, because we are going backward. Okay, now I'm getting it. Now I've got this. Okay, okay. Let's solve this after a short break. Okay, so back to the question that we were solving is race car, and now I got to know the intuition. What is the actual intuition behind the question? So this is the closest that we can go, and this is the beyond value that we can go. Now we find our answer. Now we are finding our answer. So answer can be 1 if we go beyond. So total steps taken is n plus 1 plus 1, and plus 1 is the beyond step, and plus 1 for reversing it, reversing the car, plus whatever the next will be called. So solve will be called as we went beyond. So beyond, oh, beyond minus my target. This is what is left. And plus 2. Now for int I is equals to 0, I is lesser than n. Hmm. So suppose n is 2, right? So minus 1, if we subtract 1 from here, it will go here. We subtract 2, it will directly go here. Means 0 1, it should not go to 2. If it goes to 2, then we go back to origin again. We don't want to go back to origin because we have already came from that origin. So no origins, I plus plus I. Now answer will be minimum of answer comma. Now we moved n steps close, and then we moved one step for reverse, and then we moved I steps backward, and then we called this solve. And now solve will be target minus we have the closest CLO SE we have closest, plus will be added because we are going a little back, and extra back will be power of 2 to the power I. 2 to the power 0 is 1. Are we going any backward? Hmm. Plus extra back. Mm, we can go closest is to 2 to the power n minus 1. Beyond will be 2 to the power n plus 1 minus 1. Whatever we took the step, whatever step we took, plus 2. Is going beyond minus target, obviously. Okay, for target 3, we have log 3 base 2 is the closest one. Log 3 base 2 is something. Log 3 base 2 comes, the closest is 1 and the beyond is 2. So it is going beyond. That's why I'm adding 2 over here, because we are reversing it. If not, if target minus if beyond minus target, mm, because of this we are getting 3. It's coming 0, we are returning 0. Now n is 1, 1 plus 2, that is becoming 3. Now answer is becoming 3 because of this. mm, floor of this plus 1. Even we need to, even if we, it might be possible that the closest value, if target is equals to but how, why? N is n plus 1. We went till n, 1 for reverse, I for beyond is my target. If beyond is my target, so return n. This is my test case. First is n plus 1, that is n plus 2. One left is shifted 2 times. Why? Yeah, I did the same thing. I did not use DP for now. I'm only testing. It should give me a TLE. Log to target floor. Doesn't matter. It will automatically take floor value, correct? If 1 left shifted n times means 2 to the power this minus 1 is equals to target, means beyond is equals to my target, then return n, then return n plus 1, correct? Else what I'll do, I'll call n plus 2 plus n plus 2 plus solve beyond. Beyond has already minus 1 added, beyond minus target, correct? 0 lesser than n minus 1 plus I, n plus I plus n plus 2 plus I. But why n plus I plus 1? This n is n plus 1 automatically. It's n plus 2. So n plus 1. I reversing and then reverse it again. Oh, okay. Okay. I reversed it. I moved this. I reverse it again because I need to go back again. This will be target minus 1 left shifted end time means the closest plus extra back is 2 to the power I times. This is correct. For 2 the output is 3. Should be 4. Plus I plus 1 and plus 1 is total step going beyond and then reversing back again, and plus 2 and plus 2 plus I, which is what n plus 2 plus I, because n is 1 less than 2 we need to take floor of this. Even that is the issue. No, I don't think. there is some thing that I am missing. Mistake. Or I am doing. What mistake I am doing here? N plus I plus 1. 1 my target minus closest plus extra back. Whatever we are going. And I returned. Why if my target is 2 then it's coming only 3? It should be 4. Even if I do this, so closest will be 2 to the power n minus 1. This is what I did. We are going closest. Why? It should be minus 1. 1 plus 2, 1 plus 2, it was something. 1 3 7. So why is not it -1 over here? Went here with a -1. What are we doing here? What can we do? Um, things- Go really, but I need a recursion question. and log target. Previous is 2 to the power minus 1. Current is plus 1 minus 1. Answer isn't max. Oh, what did I do? Is lesser than power. Target minus previous minus minus 1 obviously if I plus power is my n plus 1 plus the number of times I backed plus 1. Recur next beyond minus target plus power plus 1 plus 1. Okay. If target and target plus 1 is equals to 0, return target is 2 to the power n minus 1. If the target is 2 to the power n, हाँ वो केस हम चेक कर सकते हैं. That is what I checked here now. Why these two conditions, bro? Why why do we need these two conditions even? return DP of target. Even if I do plus, if 2 to the power n minus 1 is equals to target, so my closest will be n minus. Now if y 2 to the power n minus 1, that is beyond, is target return n. 2 to the power n minus 1. N plus I plus 1, obviously n plus. Still passing all but for 9 target, still failing. If dp of target is greater than or equals to 0, return dp of target. target minus and left shifted n minus 1 times. Is 1 left shifted I times. Even same thing, I'm doing 1 left shifted. And this will not do any harm whatsoever, whatever I think. Running so slow. Why? I didn't even calculated this extra back. This will also dp of target is equals to n. dp of target is equals to n plus 1 plus raise car. One left shifted n time minus 1 minus target. One left shifted n minus minus infinity is outside the range of representable values of int. Why it's coming minus infinity? Infinity for 2 base 2. Target is 2. Now target is 1, n is 1. Runtime error. Why? What type of runtime error are we having here? Somewhere or something is missing. I don't know what and why it is missing. So Java. And 10 is equals to floor of log 2. I is left shifted n times minus 1. What happened? Mistake was over here in brackets. I was not doing mistake. The mistake was in brackets. Great. So finally we actually understood this race car problem, but I know there was some problem in solving this question. It took a lot of time for me to solve it. even though I was doing correctly, but the only mistake was these bracketings were not being handled properly. So that's why I faced so many issues, wasted a lot of time. No problem. Let's take a 10 minutes of break and after that we'll start again. And this time we'll start the next question. We already solved this race car. Let me add something after this. Can I add? Maybe I'll underline it. Excuse me. Okay, I've done this. Let's take a break. See ya. We are back again. Let's solve few more questions. Okay, so this race car, I would like to keep the solution of this race car somewhere safe. But where? Hello Saurav, how are you? थोड़ी देर बात करते हैं लाइट ऑन. Race car. Just woke up. Hmm. Great. Good morning. Long time no see. If we are able to solve these two questions, then it would be great. Chat cover हो रहा corner से. Uh, is it so? No, I don't think so. और है सब तो. So the question is, given a one indexed m cross n integer matrix mat, you can select any cell in the matrix as your starting cell. Last comment not visible. It, it will be, bro. See, it is visible. It's a little delay, but it is visible. Okay. Now, given an one indexed m cross n matrix mat, you can select any cell in the matrix as your starting cell. Okay. From the starting cell, you can move to any other cell in the same row or the same column, but only if the value of the destination cell is strictly greater than the value of the current cell. You can repeat this process as many times as possible, moving from cell to cell unit. You can no longer make any moves. Your task is to find the maximum number of cells that you can visit in the matrix by starting from some cell. Return an integer denoting the maximum number of cells that can be visited. Okay. Mm. Then the maximum number of cells that can be visited in the matrix by starting from some cell. So we don't have anything to see from where we are starting. So we have 3 1 3 4. So from 1 I can jump to 3, and same row same column, I cannot jump to anywhere else. That's what the question is. I cannot jump to anywhere else. This is the only place that I can. So from -9 I can jump to 3, from 3 I can jump to 6, 6 I can jump to 7. Okay, so in this question what we need to do is we need to jump from the minimum. Even it might not be the possible that it might not be the case where I select the minimum value and start from there. uh, it cannot be always the case. So we can start from any value. Now 0 1 and 2, 0 and 1, we are at this cell. We can jump to this cell, from this cell we can jump to this cell, from this cell we can jump to this cell. Now we need to know, so if I'm this at this position, I need to know in this row and this row and this column what all values are there who all are greater than this value. We can jump to all those values possibly. Doing every time recursion is not going to help me. What is the m cross n is going 10 to the power 5. So one way that I am thinking of solving this question is picking any index and then start jumping from there. The DP will help me know what maximum jump I can take from there. If I start from here, I can jump here, but even this I need to traverse the whole area and find what all values who are greater than mm, mm, what can we do? We can jump from here to here. One way is iterate over everything and see who all are maximum and jump to that position. That'll give me a TLE. The other way to know, the other way we okay, let's try the brute force way and then we can optimize it. Even what we are doing is we are iterating over whole. if let's keep a DP. Vector mat. Now if dp of I j is equals to -1, that means we haven't visited this. So I'll call solve mat comma I comma j and dp, and then last will solve. This will contain 2D vector in 10%. This is my mat int I comma int j comma. Now if dp of I j is not equals to -1, now for same row and same column, what we can do is iterate same row and if this I and this row mat of I and R, first if R is equals to J, even that will not consider strict. It's saying strictly is greater than mat of IJ, then we can jump to this R value. Result is equals to result comma 1 plus mat comma I is here, J is here, the new value, we jump to the new index, whatever it will give me will be stored in here. Now we iterate to the same column.
mat of C 0 comma 1 plus solve of mat R C comma J comma dp, whatever value return dp of result 1 will always be there. From 3 I can jump. I cannot jump. Same row I'm iterating to same row. I0 so from 3 0 0 so 0 0 0 1 same column, so 0 0 1 0. Mm, why this is happening? For 3 1 why this should have worked, no? At least might be possible that I won't submit. We have value 3134, so from 3 I tried going everywhere, but we can't go anywhere, so at 3 we added 0 and we returned back.
yeah. It will fail. Let's say it'll go TLE. Knew that. Okay. 558 test cases passed out of 566. Okay. Now we only need to handle how we are jumping. We cannot iterate the whole. So for that, instead of not going to the values, how how can we know? Can we do some prefix? Can we keep some prefix and postfix? Maybe 3 1 6 -1 5 and 7. If we keep a prefix increasing from left, and also we keep something from right also. So from right, if we 6 is maximum, so means at this index from 3. I need to know -5 and 7. 666 minus 957. What can we do for this? I need to know what all values which are just greater than 3. All the values we need to track them which are greater than 3 on this right and this bottom. We can't iterate over all the indices. Even DP will not help me. What can we do? 558. It should not be that difficult. Apply DP solution. Maximum step can go for the first cell. And the smallest cell AFIJ will start with. Sort pair IJ with the value of MIJ and then iterate cells in increasing order. And note the current maximum steps in the same row and column. To make this process efficient, maybe I'll go for a recursive approach first or try waterback. The idea is to process cells from smallest to largest, track and increment the count of the corresponding row and column. The difficult part for me was to handle the duplicate values. We can maintain the maximum and minimum for each row and column directly. From greater to smaller, we are keeping from values. We are keeping in this cells mat of ij dot pushback ij value corresponding its indices. Vector of pair. Vector long value is equals to ARR dot size. What does that mean? We iterated over this ARR dot. Of moving in column in log and time. Use dp for every index. Call the function for every index, thinking the possibility that each element can be starting element. If we kept a map of int vector int a row, created a multi-level map of row, multi-level map of column, maximum strictly increasing cells in matrix. Maybe so. What exactly he is doing is, let's just take an example and try it. The example is 3, 1, 6, -9, 5, and 7. So we have a multi-map of m is ARR dot size, map of 0 and 1, 2 multi-map. For 0 we have a map, for 1 we have another map. Something like this. For n, it is something like that. So for 0 we pushed element, so row, so this all with the same row we pushed element with corresponding its j. This is my I. So element for 0, 3 at 0, 1 at 1 and 6 at 2. For 1, minus 9 at 0, 5 at 1, 7 at 2. For n, for 0, minus 9 at 1, 3 at 0. For 1, 1 at 0, 6 at sorry, 6 at 0, 7 at 1. This way it pushed all the elements. Now it created a DP, an answer iterated over this array ij. Now we send this row and this column. This row and column is helping me finding the answer. Okay, we'll use lower bound and upper bound obviously. Should not use lower bound. If dp is not equal to limit event, return dp answer. C is row of maybe upper bound. We can go to upper bound of this value because we need a strictly the. So this row, what is the upper bound? Even the same, there might be same value. So that's why what we are doing is we are iterating with. We found the j, so this I and this element will be my new j. Oh, understood. We needed to do some prerequisites. Map of integer, comma. Same value can have multiple indices for row. column. This will be size of m. This will be size of no. Row of I be mat of I j dot pushback column of j now 0 value 3 with 0 and like 0 and 1, 0 with value 1 and 1 and 1 with value 1 and 0. Instead of mat, do we need to keep mat also? Let's pause. Now instead of iterating, we know this is the row, this row, this row of I dot lower. अब वो कभी पीछे कभी आगे जाता है, इस वजह से गड़बड़ होता है. should not go with the lower bound. Let's go for the upper bound of matter. Yeah, two rows. Cooler sold. Bro, I am in Hyderabad. No cooler sold. You moved. मैं भैया के घर पे घूमने हैं घूमने. While all index plus plus now and ARR is equals to all. Biryani parcel. I ate biryani in the afternoon, bro. It was awesome. Don't cry. You will also get to eat biryani soon. I found an upper bound while is not equals to n. That's correct. Even we found the second value, all index second. This is my j, whatever I'm iterating. So ARR of I is my j. I'm a row and now my column. Same thing. Will be with column also. All index instead of a row, I'll call of I column j. Upper bound ij. Call of j and so this is my row. So ARR of I and j will be as it is. It's saying upper bound not found. Chalo. Okay, I should accept it. Something like this. Is it so? We can't pass it by reference. Check for row. We can't increase. I didn't increase this C man. And it's a vector of int. This should not be I. Let's take it. There's no R, right? This will be I. What happened? Let's see this test case and see if it is passing. If it is passing this test case, then we are good to go. Hey, this is even. Your code is being submitted. You're not even moving further. It's even exceeding the time limitations. See, this is also increasing. Getting the time limit exceeded for this. They added new test cases for this. Select city user. Log of maximum.
Okay, let's take a 10 minutes break and then we can start again. back. Let's go for the last hour, last question of the day. Maybe let's solve this question. The previous question was nice question, but I think they added few more test cases which was going out of bounds. But that approach is not. Join my stream, bro. Okay. Let me see your stream. Grounded. After this stream, I'll join your stream too, bro. Give me some time. Few more time. Okay. Cool. So the next question is, count k subsequences of a string with maximum beauty. We are given a string s and an integer k. I've been given an s and an integer k. Cool. A k subsequence is a subsequence of s having length k and all its characters are unique. That is, every character occurs once. Okay. Is a subsequence of s having length k and all its characters are unique. Every character occurs once. Let fc denote the number of times the character c occurs in s. Number of times the character c occurs in s. The beauty of k subsequence is the sum of fc for every character c in the k subsequence. For example, consider a, b, 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 d, d, and k is 2. F of a is equal to 1, f of b is equal to 3. Because its occurrence is f of d is 2. Some k subsequences are ab. Beauty of a, beauty of b is 4. ad. Beauty of a, beauty of d is 3. bd. Its beauty is 3, its beauty is 2. That is total 5. Noting the number of k subsequences beauty is the maximum among all k subsequences. Since the answer may be too large, return an integer denoting the number of k subsequences. As we have a1, b1 and c2, the k subsequences of s are, we can take b, we can consider b with c, we can consider b again with c because this is a new character. We can consider b with a, b with a, c with a, and c with a. So there are four k subsequences that have maximum beauty, that is 3. So the first thing that we need to find is we need to find the maximum beauty, and after finding this maximum beauty we need to find so in this case first we need to find the maximum, and then we need to find how many beauties are doing this recursively. And k is 2, that means we need to pick 2 characters.
We cannot pick B, C and C again. Correct. K is for A, B, C, D. A, B, C, D. Or A, B, C, D, because B is twice, so we can pick A this B, C, D, A this B, C, D. We can keep every character in its count, and we need to find the maximum beauty. Can we do it in one iteration? Do we require multiple iteration for this, for finding the maximum beauty? Let us keep a map of character comma integer and iterate over all the string. Now m of s of I plus plus uh, so instead of doing some, we can somehow handle this. If we have a B, 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 C, 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 C and D, D, so A, B, C and D, A, B, C and this D. Now instead of doing that, what can we do? A, B, total 3 possibility, and each one will have its count as 3, so total, so total 3 and then 4 then 2. How can we handle these things at once? Because mm, we cannot go more than nlog n. Even this is going to take a lot of time. Nlog n is the maximum that I can go. So if there is a b, we can't make a string like b a. and these will be consecutive. We kept this map for beauty. Pick, it will be pick and not pick till k. We start with index k, 0 and k. We got a string s, we got an integer id x, and we got k. Now if k is equals to 0, what is the maximum length that k can achieve? Oh my god, k can also attain a length of 10 to the power 5. Now we cannot make a dp of that much length. Cannot. Even if we try, won't be able to do that. Now if we pick and we not pick, if we pick this, what will happen? Its beauty will be added, but in future we will not consider this value again. mm. If we encounter this value again, we won't be considering this value. Correct. Even that can be handled. If we can keep a array of 26, you can see keep it as a ban characters, and we are not considering this character. If the next character comes, which is simply skip that character because that is already been picked. It's a ban character. But it will not be accepted, yaar. Greedy plus math, easy to understand, guaranteed. There are two scenarios to understand before the solution becomes obvious. Trust me, I'll make you sure you understand them. Scenario 1. Suppose k is 3. For a string containing 2a, okay, for a string containing 2 a's, 2 b's, and 2 c's, how many k subsequence of length k we can form? We have two choices, we have two choices, we have two choices. Total 8 choices. Correct. Means in these three blank we can pick A, then B, then C. Or we have two choices of 2 times A, 2 times B, 2 times C, 8 choices. 8 combinations can be made. A, B, this C, A, B, this C, A, B, this C, A, B, this C, this A, B, C, A, B, C. Okay. We have 3 slots to fill and 3 different characters. We can choose one of the 2 A's, one of the 2 B's and one of the 2 C's and put them into our answer. There are 2 cross 2 cross 2, that is 8 ways that we can form a case subsequence. Also, since we are looking for subsequence of S containing unique characters, the first order of characters in S does not matter. Sequence of S containing unique characters, the order of characters in S does not matter, correct? The order does not matter for us. This is our first scenario. I understood this scenario. Perfect. Now let's go for the second scenario. What the second scenario is saying is, let's consider the same case, but this time K is 2. Now K is 2, we have 3 characters, combination 3C2. We have 3 characters and we have to fill it in two character space. So it's 3C2. 3 factorial by 2 factorial, 3 minus 2, that is 1 factorial. NCR is n factorial, r factorial, n minus r factorial. We have 3 choices. What did we do? Answer, since we only have 2 slots left in our case subsequences, an f of c for each character is equally good. We choose 2 characters. The number of remaining slot we have out of 3, the number of candidates we have. Now I need to understand this. A string 2 is to be. This is understand that this scenario to 12 choices. We have means okay, 3C2 is what? Out of 3 choosing 2, we pick 2 characters and their frequency is multiplied with this, because these 2 slots will have these 2 characters in the 2 frequency, because we have 2 and 2. So that's why 3 into 4, that is going to give me 12 as our answer. Correct, correct. Since the beauty of the case sequence is entirely dependent on the count of each character we choose, it makes sense to start from the character with the highest count. Totally makes sense. The code isn't important. The idea is that we constructed an array pairs where, which contains element from if the number of unique characters in S is lesser than k. There is no way to form a k subsequence, so we return 0. Okay, correct. If the number of character we cannot make k subsequence, so we return 0. Conveniently sorted pairs from highest frequency to lowest. We pick the character from the highest to the lowest. If we have enough slot, that is k is greater than or equal to the number of characters with that, then we pick them all. We don't have enough slot, we choose k characters from the available option. On the pair we sorted it. If FC and OCC, FCC and OCC, what is this? OCC frequency, we sorted it on frequency and its character. If OCC is less than, we have enough slots. Okay, I understood the solution. uh, we created an array of 26 size. We, oh my god. Okay, this is for finding the NCR function for NCR. What we did is, if k is greater than 26, obviously we'll return 0. We created a character and it's in frequency is lesser than k, return 0. And create in my map. If map.size is lesser than k, return 0 again. Vector pair, and then we'll sort it with a greater highest frequency first, and then we'll start from there. And an R. So if error I dot first is equals to error I minus k dot first plus n. If I is lesser than k and error I dot first is okay. For understanding this, kth frequency, I just have to understand this part. I think I understood this question. This was not of much of a DP question, but much of a mathematics type question. Okay, so what I want to say is maybe I'll stop here for today, and I'll start tomorrow. I have something to do right now. I need to go out for now. So after I'll come back, I'll try to understand the solution again, and then I'll solve it. And maybe in tomorrow's stream I'll explain this question too. So okay, I just need to verify. Just give me a minute. Okay, okay guys. So thank you for watching the stream. I hope we solved lots of questions today. Hopefully we will meet tomorrow also. Might be possible that tomorrow's stream will be a little shorter uh, because I have something to do tomorrow. So maybe see you tomorrow. Bye bye. Hope you all have a great day.